Dr. Payne sounds a bit pretentious, so just call me Tim from now on. So the last times I've been talking to the BCS group, it was primarily on things like DevX and DevOps. But for the last probably last year and a half, I've been focusing mostly on GenAI and how to use GenAI assistants to help organizations with what they're actually looking to do. So I thought it would be interesting, given the fact that some of the conferences and some of the talks that the BCS are now giving are now focusing more on AI capabilities. I'd sort of talk about some of the stuff I've done over the last 2 years, and also talk a bit about some of the customizations that you can do with Gen AI in integrating with other tools. Because I'm sure everyone's sort of done the let's bring up the Gemini and let's bring up the Copilot and ask questions, but that's only really sort of the simple stuff of what Gen AI can do. You can do so much more with Gen AI. You can integrate it with lots of tools of your choice, and you can use the capabilities that Gen AI has to actually drive a lot of what those tools that can actually do for you. So what I'm going to be presenting today is a bit about Gen AI, the basics. I'm going to assume that, not everyone is using Gen AI. Probably very few people sort of in that category now, but we've got to start somewhere. So I'll talk a bit about Gen AI from the basic capability. So we'll talk about an introduction to Gen AI. Then we'll give an overview of the Gen AI capabilities itself. Then I'll talk a bit about delusions and hallucinations of Gen AI. People may not be familiar with Gen AI hallucinations, but it does happen quite a lot. And I can share with you some interesting scenarios that I've had in the past and in the last week or so, actually, of trying to use Gen AI and having it do some very, very weird stuff on me. Then I'm going to do a practical demonstration of a number of toolings. So I've got basically I've coded a sort of framework that integrates with various different tooling. Some of it's database, some of it's CMDB, some of it's things like Kubernetes, and some of it's things like GitHub and ADO. And I'm just going to sort of walk through those just to show you some of the capabilities that you can have when you're actually using Gen AI, and the sort of use cases that you might not have actually thought about when you're actually looking at Gen AI. And then, well, we can sort of take that. I'm happy to drive that basically based on the people's interest in those certain areas. There may be people aren't interested in doing deployments. People may not be interested in doing code reviews or looking at what the capabilities are when integrating with code repos. And if that's the case, then we can focus on the other capabilities instead. I'm perfectly open to taking that down however people want to do it. And then finally, we'll finish up with the takeaways and the QA. Now, at the end of each of these main sections, I will sort of ask if there are any questions, and we can just sort of take any questions at that point in time, just to see if there's any burning issues people want to get out. But other than that, that's the agendas for today's meeting. So let's get started.
Lovely.
So Gen AI introductions. So I'm going to assume that going from basic level, some people may have used Gen AI quite a lot. Some people may not have used Gen AI at all. Some people may have just heard the term and have no idea what it's about. So this section is really just to give you a quick intro into what Gen AI does, some of the issues that it has, and how it differs from more traditional AI. So in the simple terms, generative AI is basically about taking patterns that the pre-training has done. So you take a model, you train it on content, and then you can use that trained content to generate sort of unique content that looks like it's been similar to human generated content. So you can sort of ask questions, it will respond in a native language way. So it will retain context, it'll understand the sort of concepts that you're talking about, or at least it will seem to understand the concepts that you're talking about. Not always, but most of the time. It will sort of generate images, it can generate multimedia. So the idea of Gen AI at a high level is that it can take queries that you pass in, and it will respond as almost as if it was a human and generate content based on the pre-training that those models have had, and then sort of respond to your queries, give you context, and then it allows you to sort of follow up on queries that you can sort of say, well, I asked this question, I got this response, and I ask another question, and it will use the previous responses to give it better context. So the more questions you ask, the more context you give it, the more better those responses will be. So if we wanted to summarize that as a couple of key points, so generative AI is about basically using deep learning based on pre-training data sets that it has to generate content that can seem like you're talking to a human. It can understand natural language, it can retain concepts and contexts, and it can give you responses that actually seem like it's understanding what you're doing. And we'll talk a bit about how it does that later on in the presentation as well. There are a number of main models, obviously, that people use. The biggest two are Gemini and ChatGPT. ChatGPT is also based on the OpenAI standard, which also uses which is also used to implement Copilot. There's also Llama, which is done by Facebook, or Meta as it's now called. That gives you certain capabilities, which I'll also talk about, which the other two don't. So you'll probably use Gemini, ChatGPT, or Claude, or some of those other models. And basically they will sort of respond as if you're asking questions based on the data that they have. Oh, I need to understand how the Zoom works as well. Right, so was it some of the key differences between Gen AI and traditional AI? Now, if you're like me and you've done some traditional AI in the past, you're probably familiar with things like decision support systems, frame-based systems, where you sort of went and you gave it loads of data and you were relying on the actual AI system that you were implementing or that you were using. Maybe you're using Sage, maybe you're using fuzzy logic. Or if you really go back, maybe you're using Prolog to generate frame-based classes. Basically, the main point of digital AI was that it would analyze the data that you gave it, and it could then predict and label data based on the sort of algorithms that you put in, the decision trees that you put in, and the learning that it did from those classification algorithms. The main difference between traditional AI and generative AI is that it goes that next step further, which is basically it can take the patterns that it analyzes, and it can use neural networks to actually understand the context of those patterns. And it uses something called transformers to actually understand how sort of language relates to each other, or how chunks of data relate to each other. And it can learn from those patterns and then use what it calls a transformer neural network using sub-attention, I think it is, the model, to actually generate content back or respond with content based on what it's learned, to sort of emulate what you'd call natural thinking. So it's not actually thinking, it's not an intelligence in itself. All it's doing is just mimicking based on the understanding of the positioning and the context of the data that you provide it. So it uses what's called vector analysis to understand the data, puts it into a neural network, and then it uses this attention model to actually understand the contexts of the positioning of the data, and then basically use that to generate or synthesize responses based on its understanding of the patterns that it has, so that it can actually look like it's actually responding to you in ways that actually seem natural based on the data that it's actually learned from. So the more data that you can actually give a generative AI model, the better the responses that it actually generates you. So if you have models that are trained on very low levels of data, then the responses that it gives can seem pretty weird. If you use one of the GPT models, which are basically pre-trained on large data sets, which are sort of general data sets, then the actual responses that it gives back are very good, and they can seem very natural. But it's all sort of I wouldn't call it fake and mirrors behind the scenes, but it's all based on the sort of understanding using these neural networks of the context of these languages that you're putting into it, which are these vectors, and how they relate to each other. And then it's using that to sort of synthesize responses that sort of are based on the vectors that it's already learnt about. So, as I say, why it seems like it's intelligent, it's actually just doing pattern recognition and responding based on these vectors and these sort of how it understands how these vectors combine together to give results. So that's the main difference we're talking about with traditional AI and generative AI. Traditional AI is basically it learns patterns and learns to predict based on information that it has. So it's mainly about things like labeling, using classification models. But generative AI, the main thing about that one is it goes that next step forward, where it can actually understand the context of the data, how each of those data relates to each other, and then sort of synthesize content or responses back to you based on its understanding of how those data relate to each other. So why is GenAI so big now? Obviously, I think the first paper that mentioned GenAI was actually in 2017 or 2018, but it's only really within the last, let's say, 2 to 3 years that it's really been such a driver for businesses, or let's say it's been coming to the attention of so many businesses as of something that they really have to do and really have to dig into and use to help support what they're actually doing with their business flows and what they're doing with their sort of data. So why is that sort of coming up so much now? The key reasons for that are the fact that since 2018, there's been a breakthrough in how the architecture understands, or how the underlying sort of transformation models and how the algorithms used for doing those transformation models can actually break down and understand the data that's been given. So as I mentioned, these neural networks and this sub-attention model, it's only really that since that's been implemented that you're able to actually get models that are out to people that can actually understand data, and that people can actually use in the sort of ways that they will allow them to experiment with. So we're also seeing it with Google and AWS and NVIDIA and Azure. Yeah, that's the last one. An explosion in the ability of how much computing power that people now have in data centers. So one of the sort of blocking things that used to be in the past was how many sort of machines you could actually throw at these data sort of sources and actually get them to process this data and be able to make some contextual sense of it. So with all of the data computing that's now out there, you've got data centers all over the world that Google have, Azure have, and AWS have. It's this sort of computing power and the advances in the GPUs that those computing power are now implemented on top of that actually allows you to sort of generate these models that allows you to actually get these responses back and actually look like you're actually doing things intelligently with these actual models that you're creating. So the fact that these transformation models are now available, the fact that you've got these computing power that can actually allow you to make use of these models, the fact that you've got large data availability sets, so you've got large amounts of public data, you've got main suppliers sort of putting these into pre-trained models and making those available open source or at least proprietarily available so that you can actually use them. The fact that you've got these models available that you can actually have APIs that you can use to integrate with these models. All of that is now driving a business demand for being able to use the power of these AI models and actually do something with it. So all of these are helping to combine and drive the fact that organizations are now wanting to experiment with these new AI models and just see what they're capable of. And there's lots of use cases that they're now actually using these AI models for. So some of the ones that I've been okay, there's just the explanation of what transformers are, which I've already talked about. But the one of the main use cases for these sort of models that I've seen in the last year or so, there's low code, which is also known as vibe coding, which is basically the ability for developers or QA or people who are DevOps engineers to integrate with things like Amazon Q or Gemini or ChatGPT, and basically give some general requirements, like maybe, I want you to generate me some code or generate me a workflow that will do X, Y, and Z. Put that in, and then suddenly you have some code that's generated or a workflow that's generated that is probably about 60% there, or gives you a very good starting point for being able to actually generate working code or working system that you can then make use of. So a lot of the code that I do these days, I start out by putting a set of templates into Gemini. I basically give it some general parameters of what I want it to do, and it will generate out a set of working code, or at least a sample of set of code that I can then start and use that to generate a basic working system from which I can then start to incrementally change and add more functionality to. So it's a great way of being able to get organizations started, even if they're not familiar with certain coding styles or sort of certain coding languages. Some examples that I've seen over the last couple of years are when we were working with Lloyd's. We used AI there quite a lot to actually generate Terraform. So Terraform is the language that you use to spin up infrastructure on some of the cloud providers. So we used the load coding practices to basically be able to generate Terraform packages to start off with, and then basically that would cut down the development cycle quite significantly. And the more samples we created, the more examples we could give it, the more that cut down the initial development cycle. So we found that by being able to use load code or vibe coding, however you want to call it, we could get developers and people who were not developers up and going with working code in a lot more quicker than we were able to do in the past. So another use case that I've seen quite a lot, especially with one of the customers I was working with a couple of months ago, is where you're looking to generate knowledge assistants. So knowledge assistants are where you sort of take lots of data. So you may take lots of company process data, process documents, HR documents, wikis, IT tickets, HR templates, maybe information about how the HR processes work in your organization, and you basically set them up as data stores, and you get the knowledge assistant to basically analyze that data, pull it in what's called a vector database, and then you can run queries on it. So it's something called RAG, which I'll talk about in the next section. But the idea is that you can sort of have a single portal that is attached to all the data sources within your organization for business information. It might be process information, it might be standards, it might be, as I said, wikis or IT ticket systems. And you can go in there and you can say, what is the process for ordering a new machine? And it will automatically, it'll then use the knowledge assistant to retrieve that information, tell you in that single portal, and you don't have to go scrabbling around lots of different wikis or process document sources to actually find out this information. And because you can actually integrate it with ticketing systems, you might actually, one of the use cases that we had was to be able to sort of go into the knowledge assistant, say, I am a developer, I'm starting with a new in a new role. I'm wanting to get access to these particular systems. Can you raise a ticket for me, or all the appropriate tickets for me, so that I can actually have access to these systems? And the knowledge assistance can, it knows what it uses this RAG method to sort of work out what processes it needs to follow, what business tickets it needs to raise, and it will do it for you automatically. So, we try to use these sort of systems to cut down the amount of admin that people are doing, cut down the amount of support work that people are doing, and also make people more productive. So they've got a single portal they can go to ask all these questions and then kick off all these business processes. And the customers that we've been worked with have found these extremely useful. Another good use case is emails assistance, and this is where you're basically primarily support staff. That might be customer facing support staff, it might be IT support staff, and basically that a lot of the time during the day they're sort of responding to emails. The idea of these emails assistants is that you can use GenAI to go and analyze all of these IT systems, all of these wikis, all of these HR systems, generate, get all the information from there, and then pre-generate a response for you. So it can basically say, oh, I've got an email that's talking about, a support request. It's someone sent me something saying I need you to, add me to this particular system, or order me a laptop, or it might be a response, might have some queries about some HR policies. What you can do is the person who gets email can just say, generate a draft for me. And then that's done automatically by going off to these knowledge assistants or going off to these ticketing systems, get the information from there, generate a draft automatically, and the person doing the support team just needs to basically read the draft and say, yep, that looks okay, and then basically send it off. So all of these sort of use cases are aimed at sort of trying to leverage the business data that organizations have, whether they're scattered in wikis, whether they're scattered in cloud storage systems or SharePoints or whatever, and sort of bring all that information together and then utilize it to help people be more responsive, basically, help drive what they're doing a lot easier, rather than them sort of having to go into ticketing systems or go into lots of documents and try and find out the information and then respond to the people asking these questions. Last sort of main use case I've seen is where you're using it for data analytics. So one of the main use cases I did with this sort of in the last 6 months was where a customer, I won't name the customer, but they basically had lots of test data, and they had lots of this test data was being contributed to by lots of different teams. Some of the test data was legacy, some of it wasn't, and they were having to spend lots of effort and time trying to sort of use test data management processes on this test data, trying to validate whether this test data was correct, trying to identify conflicts in this test data, because they were having lots of false positives that was relating to the different versions of this test data that they had around. So we wrote a more complicated version of some of the tools I'll show you today to sort of go into this test data and identify things like PPI information, data inconsistencies. So, for example, one of the good use cases was where you had a customer ID. The customer ID was shared in different formats in different databases. So in one database, the customer ID might be 00 hyphen 00 hyphen 123 hyphen something. And in another one, it would be 0000 12300 or something like that. So it's the same sort of customer ID, but just in different formats. So when you actually try and write, developers would try and write queries to join them together, the results weren't being found simply because the data was in inconsistent formats. So we sort of were using these data, tying data analytics tools into GenAI to try and get the help drive some of these analytics to sort of say, identify cases where data was being inconsistent. Some of the formats of the data were inconsistent. Dates were inconsistent, or data was being duplicated around. So we gave people an interface on top of, or a GenAI interface on top of some of these tools, and then they were able to use that to sort of proactively, how they wanted to, mine into the data, identify inconsistencies, and then even fix those inconsistencies by basically using some of the capabilities that you then tied into the Gen AI tools. And I'll take you through how we did that later on in the presentation, because that was a use case where Gen AI sort of helped significantly resolve a lot of these inconsistencies that had been in these data sets for a number of years, shall we say. And that certainly helped the productivity of the test teams in being able to actually identify test cases that were generating very weird results, and sort of try and fix them. So any questions on that so far? Some of it might be a bit basic. Some of the ones that I'm going to be talking about more goes into some more of the technical details about Gen AI.
Lovely. I'm sure people will be keen to get onto that. But just before we do, David has raised a question. He was just wondering whether GenAI could help with problem management. So joining the dots across a number of systems and people.
Yes, it certainly can do. But when it comes to identifying what the problem, so Gen AI is very good as an orchestrator. So you can basically bring different information sources together and get the Gen AI engine to sort of make inferences from those different data sources to identify where you've got potential problems. So I don't know the specific use case you're looking at, but you could plug different systems in together, bring information in from those different systems, and then sort of use the Gen AI as a reasoning engine on top of it to identify inconsistencies in some of those data sources or potential gaps or problems. So one of the use cases I was going to show was sort of using Gen AI to do things like code reviews, and then sort of identify security loopholes or security improvements that you could do on top of code. So yeah, Gen AI is very good at coordinating information from lots of different sources and then using its reasoning capabilities based on the goals that you give it to sort of manipulate that information and understand that information and sort of generate results based on bringing that information together in line with the sort of questions that you have. So if you've got a particular problem that you're looking at, then you really got to understand what that problem is, what the data sources for that problem might be, and then you'd sort of do some of the techniques I'm going to show you in a couple of slides time to sort of merge that information together, and then let the Gen AI reasoning engine sort of look at it, and then try and you provide some prompts, and it will basically then do the analysis that you sort of ask it to do, if you like.
Okay, lovely.
Probably, more about the problem to answer that.
So perhaps I could have clarified the problem management. We've got a lot of people on the call who understand the ITIL process of problem management, which is looking at a series of incidents and trying to identify any common themes that are running between them to look to the background. But perhaps rather than getting stuck into that now, if you've got use cases around that, we can maybe look at that in the demos later on.
Well, when I was talking about that you remember I was mentioning that knowledge assistant and the emails assistant. One of the things that we did for that was we integrated into the problem management systems, so the ticketing systems, so IT ticketing systems, and we actually used that to understand common scenarios that had been related to the problems that people. So if people had like a hard disk problem, or if people had a certain IT, a problem, a symptom with an IT system that they were trying to raise a case for, the knowledge assistants could use those as data sources, and it could mine those data sources to find tickets that were very similar to the problems that were being talked about, or maybe exact cases to the problems that were being talked about, and then basically pull out the results, and then just say, if you've got this particular problem, this is what you need to do to fix it. So you could use those sorts of systems to generate a almost like a playbook or a run book on how to fix problems. And when you're doing the data analytics, you can also plug into those systems as well, and you can sort of ask it to do trend analysis or identify common types of issues that people are having. So we use that for in these knowledge assistants as well.
Okay, lovely.
So certainly, in answer to the question, certainly.
Yes, I think one of the other concerns is about how the costs and the issues around using GenAI systems. So one is that you may be having to pay for these systems, and the other is that in sending out your context and your prompts, you may be releasing information about your confidential customer, your internal IP, that how can you
don't want
make
to.
sure that exactly. So
there are certain things I'm going to be talking about that later on. So keep that in mind. In a short answer, there are ways of stopping the so there are enterprise versions of both Copilot and Gemini that you can use that won't leak information. But that's certainly a concern for you if you're using the open, not the open source versions, but if you're using the like the standard versions of Gemini or Copilot or ChatGPT, then there is definitely an issue where it will leak data, because it sends it up to it doesn't do the analysis on your local machine. It will send it up to the cloud, and the cloud vendor or the cloud host effectively will pull that data apart, and it will be part of the public domain from then on. So yes, it's definitely a very valid concern, but there are ways around it,
including paying for privacy. Excellent,
thank you.
Paying
for privacy, yes.
Okay, right. Thank you very much for your questions, David, and let's carry on.
Okay, I'll get used to Zoom one day. So next one I'm going to be talking about is mainly a bit more on the internal side of GenAI. This is sort of going to be talking about things like how to do call outs, things like how to do RAGs, and some things on the pay, how you pay for GenAI, and the sort of data leaking as well. So what we're going to be discussing is some of the core GenAI concepts. We're going to be talking about some of the terminology that GenAI uses, things like prompts and roles. These are more focused on some of maybe the internal application. If you're looking at starting to write applications within using GenAI, or integrate custom services into GenAI, prompts and roles will something that features very heavily. But I'll cover those, and you can use them with standard ChatGPT and Gemini as well. But they sort of have more use cases when you're looking at integrating other tools with GenAI. We'll talk a bit about RAG, although I've already sort of covered a bit of that already. We'll also talk about how you integrate custom callouts and tools into GenAI, which is the main point of really this conversation. And it's really where you start to get the core value from GenAI. I mean, GenAI is very good by itself, but it's sort of a bit flat with what it can do. The value of it and the sort of extensibility of it is when you start to put in custom tooling or custom data into it. That's when it can really shine with what how you use it in your organization. And also talk about some of the key differences between some of the main GenAI providers, and some general terms that you might want to look out for in the future, but that I'm not going to be covering here specifically. So what are some core GenAI concepts? Well, GenAI uses this concept of roles to basically guide what both the models do, and also help it understand your persona as well. So I'll talk a bit more about roles later on, but basically you can use it to sort of focus the actual responses that the GenAI is giving you, and make it more specific to what it is you actually want the GenAI to focus on. If you're using something like ChatGPT or Gemini, then you haven't got an assistant that's sort of focused on any specific role. What you've just got is like a general, I know everything, and I may have delusions and hallucinations about everything, but you can ask me any specific question, I'll give you any specific answer, and that might be too generic. Say, for example, there was a case earlier today when I asked a specific question and it got the context wrong because I wasn't being specific enough about the information I was after. Roles allow you to do that transparently. So I'll talk a bit about those. Oh, come on. I'll also talk a bit about prompts. Prompts are basically the queries that you give a GenAI model. So when you give if you look at the interface or you're talking to it and you give it a question or you give it a query, that's effectively the technical term for that is a prompt. And you can use prompts to basically overcome some of the problems that GenAI models generally have, which is things like giving inaccurate results or giving results that are too broad. So there's something called prompt engineering, which I'll talk a bit about, that you can actually use to help fine tune the responses that you get and make them more consistent. Oh yeah, sorry. I'll also just introduce one term, that's LLMs. That stands for effectively large language models. So Gemini, Claude, ChatGPT, they're all versions of large language models. So if I talk about large language models, then I'm talking about just GenAI models. It's just a general, another more specific term that sort of focuses more on the models, without going into saying it's a ChatGPT model or it's a Gemini model. It's just a large language model. So I use that term quite a lot throughout the presentation. That's what I'm referring to. So LLMs, we can also, we talk about using data sources, and I'll talk about this RAG, which stands for Retrieval Augmented Generation, to basically show you how to do that sort of knowledge assistant case where you can sort of attach different data sources to GenAI, and then you can sort of use those to ground the results better, rather than just relying on the pre-trained models that you get from Gemini or Microsoft. Or sorry, I should say OpenAI rather than Microsoft. And we'll also talk about how you can integrate these tools, all these custom applications into the large language models, so that you can sort of draw on not just information, but you can also get the GenAI to actually do actions. So if you want to create a ticket, or you want to sort of do a deployment, or you want to kick off a build, or you want to sort of do a physical code review, I'll talk about how you can actually put that into the GenAI model, so that if you can say, go off and create me a ticket on this particular system about this particular topic, it knows how to do that, and it will create the ticket for you, rather than just pretending it doesn't know how to create the ticket for you. And lastly, I'll talk a bit about how the results are returned to users, and how those are sort of used or held in a stateful sort of session to sort of help make those results that you have more contextually meaningful. So basically what I'm saying is that the results that come back are stored, and the sort of it keeps each session that you do keeps a history of the results that you have. So the more that you sort of ask, and the more state that you add to those previous results, then the better the responses are, and then the more you can sort of be less specific about the questions that you have. So you can sort of say, connect to this database and do this particular operation, and it will remember the fact that you're connected to a database. And if you say reconnect to this database, you don't need to give it the database actual connection details, because it will already remember the databases that you've talked to in the past. So it's just basically saying that the conversations that you have with GenAI is stateful, and that wasn't so much the case in the past with the traditional AI approaches. So let's start off by talking about what are roles and prompts. So prompts are basically just the instructions you give to a GenAI. They might be the things that you type in at the sort of the nice GUI that you have. So if you open up your ChatGPT window and you type in a query, that's basically a prompt. So an example of a prompt might be, generate me some SQL to create an Oracle database. Prompt engineering is where you're actually looking at modifying those prompts or making those prompts more specific to get you a better quality of answer. So if you sort of put in a general prompt at the start, we may get a result back which isn't really quite what you want. So you then you fine tune that prompt to get the more specific results that you're after. So you may just say at the beginning, tell me a bit about MCP, or tell me a bit about Oracle databases, or tell me a bit about this particular problem. So I've got a ticket that is showing the symptom. What is this problem, or what might it be related to? You'll get a response back initially that might be very broad, and you want to fine tune that result down to something you can actually make use of. So the art of prompt engineering is being able to sort of fine tune those prompts so that they give you a result which is more specific for what you're after. And if you're sort of doing a one-off, then prompt engineering may not be quite relevant for what you're looking at. But if you're sort of doing the same sort of operations many times, then having a library of prompts which are sort of fine-tuned to give you the same sort of give you the actual answer that you're after, maybe within one or two queries, that is something which is very useful. So the more repetitive the prompts are that you use, and the more sort of specific the results that you're after, then having a set of prompts which are that you store and that you use often can be very helpful. So that's sort of what prompt engineering is about. It's basically looking at how you build up your prompts to give you results that are more accurate and more relevant to what the questions you're actually asking, so that you can sort of repeat them rather than sort of having to sort of go down into 5 or 6 queries to get the answers that you're after. A system role is something that you can use to actually specify how the system is going to respond to you. So it's a way of being able to contextualize and limit the actual responses that the models will give you. You can use them with standard GenAI tools, but they're more specifically related to when you actually start to look at coding with GenAI. So a system role is extremely important when you actually look at coding something, because it can sort of focus the models that you're using and sort of limit the responses that they give to the things that you're specifically interested in. So if I'm an expert, or if I want to limit the responses that the model gives me to something like data engineering, or just to coding, and I don't want it to sort of go off and sort of look at travel systems. I don't want to start giving me responses about travel requests, or how countries work on political systems. Then you can use what's called a system role to limit the behavior that the GenAI model does, or the LLM does, to just specifically what you're after. And you can also tell it to how to format the response. So you can sort of say, give me the response in Markdown, or give me the response in HTML, or give me the response in a summary format. You can use it to tune the behavior of the of the model and how it responds to the users without having to put that input in every time that you actually want to start talking to the model. It's like preloading how the model's going to behave, which is very important if you want to sort of set up specific behavior for particular models, and also cut down on the amount of BS that the models return to you. And the last one is what's called the user role. And this is the persona that you're actually interacting with the model. Say I'm a developer. You can actually say, I'm interacting with you as a developer, so treat me as if I'm a developer. Or if I'm a tester, treat me as, use tester specific terminology. If I'm a support engineer, I might say, I know how to work with support engineer sort of terminology, so treat me as if I'm a support engineer. It's basically a way of being able to get the system to respond in certain ways using a system role, or get the model to treat you as if you are one of these X, Y, and Z people, where you can specify a persona and you can get it to behave as if you are one of those personas. And again, it's more relevant to coding or to interacting with models under the hood, rather than the actual specific use cases for just going into and using the standard models. But they are very important if you actually start to dig under the hood of how the GenAI works and how you want the GenAI to actually respond to you. So, as I said, the key difference for a system role and a user role: a system role defines how the model works, the boundaries that the model has and how it responds, and the user role is basically just defining who the model is interacting with, so it can sort of respond to you as if you were one of these particular personas. And then that sort of governs how the model works with you and how you work with the model. So I've got a good example of what I call a good system role. This is one that I sort of have used in the past. I might have a developer version of this, might have a DevX version of this, might have a tester version of this, might have a data engineer version of this. But basically the idea is that you preload this, or that the AI, the GenAI tool, will preload this every time it works with you, and it will respond as if these are part of the instructions that you give it. So in this case, I'm telling it the scope of the role I want it to act as. So it's saying, I'm going to be talking to you as if you are an expert on coding, and that you know things about databases, you know things about infrastructure, you know everything about programming languages, you know things about security issues, you know things about databases. I only want you to respond to me on queries on that sort of role. So if I ask you about legal stuff, or I start to ask you about HR policies, you will respond to say you know nothing about that. So it's a way of being able to sort of roll out systems to people and tailor the responses that those systems give to the people that are the actual audience for that. So if you've got a coding assistance tool, you can basically only get it to respond to particular coding. You might also put in things like here, like standards. So you may say whenever you generate responses, do it in a particular standard. You might say, I want you to talk to me as if I'm an adult. I'm a professional. I want you to respond as a professional. Or you might say, I want you to respond in a simpler way. Assume that the people that you're talking to is not a professional, knows nothing about coding, knows nothing about ITSM, knows nothing about ITIL, and then sort of respond in more simplistic terms, explaining the terminology, because people may not be familiar with it. So you can actually govern how the model works. You can govern how it responds. You can govern the format that it responds in. So you may want it to respond in rich text. You may want it to respond in Markdown, which is another form of rich text, or you may want it to only respond in ASCII text for whatever reason. You can put that into this system role, and any responses that come back using that system role will comply to these sort of directives that you've given it. You can also use this to sort of try and cut down the amount of potential fake info that it gives you. So if I want you to sort of not respond, if you're not 100% certain about the response that you're giving me, so maybe I ask you a question and you're relying on sources that might be a bit iffy, or perhaps potentially it's a response that's not grounded in data that you have, then just don't respond. Tell me you don't know the answer. So that sort of helps cut down the amount of hallucinations that AI models might have. So in this example here, this is for a sort of like a developer or someone who's doing system engineering or DevOps or an SRE engineer. This might be something that I would use if I'm writing a system that's going to be focused at those particular users, to actually limit the information that they have and focus it really down on the questions that are relevant for them specifically, and also cutting down the amount of potential fake information or inaccurate results that might be given to them. So it's a good way of being able to basically limit what the models actually do and how they interact with the end users.
There's a question, sorry to interrupt there.
Yeah, sure. Go ahead.
David's just come up with a question that's very relevant and specific to that, to know, is a system role generally hardwired in? If you're saying if you give it directives here, could they be undermined by a text prompt later on by somebody interacting with the system?
Theoretically, yes, it could be. You can get around that by basically sort of saying, you can tighten these up to basically say, you will always do these, you'll always do something. But there's always a ways around everything. What if you wanted to really tighten it down, you could say, you will never respond to something, or you will never talk about something, or you will never do this particular operation. And then because these system roles are always loaded for every query that you give, in theory, that should then override that. But GenAI is, shall we say, well known for ignoring things sometimes. So what I would probably do is I would emphasize never by putting it in uppercase, because these models do understand things like emphasis. So if you say, you will never in uppercase do something, then it will take that never more seriously than if sort of someone put in something else. But again, that's where prompt engineering comes in. You'd have to experiment with these prompts to sort of clarify how you want that tool to respond. So the answer I'll give is yes and no, depending upon how you engineer these system roles. But these system roles are your first level of defense, if you like. But there's always ways of undermining them. So I'm not going to show you the sort of code, but I wrote an email assistant recently, and I had to put into that email assistant rules that were very, very specific about what the email assistant would do. So I would say, you never do this, you never do this, you never do this. And the best way I found it to respond to those sort of rules was if I put in never in uppercase, because then it would sort of ignore some of the other prompts that people might potentially give it.
Right.
So it's basically a question of experimentation and prompt engineering to get the prompts that work best for you.
Thanks.
Okay. So I talked about RAG. So RAG is retrieval augmented generation, and it's basically used where you sort of have lots of data sources, and you want to pull those data sources in and then get the GenAI to actually use those data sources to ground the responses that it actually gives you to something that's more contextually specific for either the domain area that you're in or the organization that you're working with. So as I say, most of the organizations that I've worked with that are using sort of RAG models or RAG tools are where they want to bring lots of data from lots of different diverse sources. That could include databases, it could include wikis, it could include structured, unstructured process information, it could include IT systems. Amalgamate all that information together, and then allow people to query that information and then make use of it. So the query is the retrieval, and the augmented generation is basically using the LM to augment that information and sort of generate a result that's more in line with the prompt, and it sort of basing some analysis or some generative enhancement of the information that it actually gains from these various sources. So as I said, RAG stands for Retrieval Augmented Generation, which is a real big mouthful. So I just always call it RAG. It's used to pull information from lots of external sources. So as I said, that could be wiki, problem systems, it could be IT systems, it could be process documents, it could be anything really that you can connect as a data source. And then it will use those to sort of ground the results that you're actually asking for. So if you're actually, if you want to ask for a specific IT policy or a specific HR policy, it will use that data to actually ground the response that it gives you. And when I'm talking about grounding, what I'm just saying is it will reference an actual. It will use the data to make sure that the response that it gives you is actually grounded in reality. I think that's where the term comes from. So it's basically just a way of saying it's grounded in actual information that has relevance to your business or the domain space that you're looking at. It uses vectors. So vectors are sort of numerical summaries of data that are used to compare, group, and retrieve related content. I did know how they worked at once, but don't ask me to sort of reply, to sort of say how they work now, because otherwise I'll start to cry. But basically, when you look at RAG systems, what you'll see is something called vector databases, or vectors, or creating vectors. And basically all they are is just numerical representations of data. And then the LLM uses that to compare and contrast these different chunks of information together. It's just basically a numerical way of representing data. LLMs, once they get these vector information, or it's done a vector search, it will then collect these various sources of information together. So it will summarize relevant results from these various sources, and then it will use that as input to basically augment and generate new results based on the information that it's gathered. So you could view it as like the retrieval is going to the vector database to get all of the information that's relevant to the query that you're asking. It will bring all that information together in a set of results, and then the LLM will basically take the prompt that you give it and the goals that are in that prompt, and then it will basically organize that information and augment it to give you something that's more relevant to the question that you're asking. And then that's where it gives you the augmented generation and pushing that to the results that you get. So that's a very quick summary of RAG. There are a number of tools that you can use for RAG. The offerings that come from GCP. So this is an area that sort of only come up recently. I wouldn't say very recently, but it's something that the cloud vendors are only jumping into recently. So literally earlier this year, Google released the first version of their sort of tools or suite of tools that are sort of looking at this sort of area. It was called Agent Space at the beginning. Well, it was called Vertex AI at the beginning. Then it was called Agent Space, and now it's within the last week or so, or last 2 weeks, changed to Gemini Enterprise. There's another. So Gemini Enterprise is good because it's basically a suite of tools. It's something that's generally easy to create. What you can do is you can just generate, it has a GUI, you can generate, you can connect data sources to that GUI, and then you can create what they call an AI app, which sits on top of those data sources. And then you basically publish those data sources. You wait a couple of hours for it to create the vector database, and then you can go in and sort of, it has options for either doing it via a REST API or its own native AI, or a combination where you can actually take a text widget and embed it into your own sort of GUI, and then you can sort of just pull information from that vector database. I used it very, very recently. It's quite good at what it does, but it has some challenges that sort of it needs to build on. It's sort of like semi beta. It's not beta, it is production quality, but it's some of the tooling around the sort of data sources you can connect up to it. Some of those aren't fully fleshed out yet. So it's a mixture of sort of both beta and production quality. LangChain, I throw that in there because it's the main tool that you use from a coding perspective. It's mostly from memory, Python based. I think it's got some GUIs associated with it, but it's really a framework that allows you to build code. So unless you're into Python coding, it's probably not something that you'd really want to focus on. And if you want to get into RAG at the start, then you're probably best using Gemini Enterprise or similar equivalents within the Azure and the AWS. I'm not certain what the AWS equivalent of it might be SageMaker. It's not something I've done in AWS, so I wouldn't really know the great tool there. There is Elasticsearch or Open Search Service. I think you can do something similar within the Open Search Service that AWS has, but it's a lot more finicky, and you've got to do a lot more tools, connect them up together. So if you want something that to get you started, Gemini Enterprise is probably a good option, and you get a 30-day trial for using it.
Okay.
The last one is OpenAI API and VectorDBs. That's more of it's more of a framework for combining different tools and different types of vector DBs together. I've not used it, but there is a link in the presentation if you want to go and have a look at some of the cookbooks for it. So RAG will be something that will come a lot more relevant as the years go by. I suspect a lot of the organizations, as I've been working with, they've been waking up to RAG. They've been sort of having business cases for it, either as assistance or as plugging it into other tooling, say like email assistance or support assistance. It's all just different variations of RAG. So it's something that I would highly recommend you sort of look at, get familiar with, because it's something that's going to be becoming a lot more relevant to the GenAI space as we go along.
Thank you for also answering Hunter's question as to whether agents or assistants would be an example of RAG. So yes. You've covered that. Well done.
Cool. Right. So now we start to look at the custom. This is really the main last technical bit. This is where we start to look at how do you put tools into AI models. So when you have an AI model, they have this capability called tooling. And tooling is basically just a way of calling out to functions or to REST API calls or API calls or whatever it is. And basically what it does, you can use metadata. You have what's called a metadata sort of engine, if you like, database or something. You register a tool with a GenAI model, and then you can specify some description about what that tool does and description of the parameters. And then what the tool will actually do is it will look through that metadata, and it will see if the request that you give it or the prompt that you give it actually relates to some of the metadata that's associated with those tools. And if it does, it will try to map parameters to those tools and then actually invoke that tool and then use it to give you a response. So you can use it to integrate to things like to do code calls. You can integrate it into databases, ITSM systems, problem management systems, just by using their API. So effectively, you would say, I've got a set of APIs that I'm going to use to get particular information back, or do particular actions. I will code up those APIs. I will create a tooling interface, a tooling function for it. I will register that tooling function with the GenAI, and then I can say things like, go away to this particular system and get me all of the tickets that might relate to a particular a user, or get me all the tickets that might relate to a particular problem, or go into the tickets and then sort of search for the main common problems that people are raising. So it's here where you actually start to get the main benefit of doing things like data analytics, or building in sort of custom solutions that you want the GenAI to basically be able to do. So you can use it to either pull information from tools, or you can use it to actually kick off processes within tools. Depends upon the actual tooling functions that you write. So effectively, if you have tool sets that you want to integrate into, and they have APIs or methods of calling that are headless, i.e. CLI, or API functions, then you can write tooling function for them, and then you can also get the GenAI model to actually work with those systems as well. And that's what I'm going to be demonstrating quite a bit in the second session that we have after we go through these slide decks. And if I talk about how these work, basically tools are functions that you register with a GenAI model, and they provide the capability for the GenAI model to go off and do customized functionality, whether that's actions or getting data back, or both. That's up to you. The tooling metadata that you provide is how the GenAI model can match the prompt that you give it, or the request that you give it, with the tool that it actually has. So if you give it a good description, it can match. You sort of say, okay, what's the sort of verbs I'm going to be looking at? So things like review might be a keyword that you put into the description. So if I have a particular thing to say, I want to create a function that's going to connect to a database, you would say, this is the function that you use to connect to a database. And then the parameters would be, this is the schema name, this is where the database, the machine that the database sits on, this is the port that you listen to it. And then you basically, if you've got those descriptions done in a good way, you can sort of use any sort of combination of English to sort of say, either connect to this database on this machine, or you can just say connect machine database things. The GenAI will actually use its processing or reasoning capabilities to actually try and match as best as it can the prompt that you give it with the tools that are registered. And if it gets a good map, it will then invoke that tool and pass in the parameters to actually do the operation that you want it to do. So I'll show you some examples of that as we go along. So the LLM uses the metadata to match the queries to the tools, and then it will basically run the tool and get the results back from the tool. And then it will process those results as if they were something that came from either a RAG source, because effectively this is like a RAG tool as well. And then it will basically use those results to drive more processing. So it may look at those results and say, yep, that's the sort of information that I want. I don't need to do anything else. Or it may look at those results and say, okay, that tells me something, but I need to go off and do some other tool invocation to get maybe some more specific results. So when you look at writing these particular sort of GenAI tools, what you often have is lots of loops in there. So you might have lots of loops where you're basically saying, I want you to go and invoke these tools multiple times based on the intent that you give it or the goal that you give it. And it might go off and talk to lots of different tools to different parts of that answer. And then when it's got all the information that it needs and it's processed all the information that it can do to reach the answer that it does, it'll then decide, yep, that's the final result. So that's called the final result, surprisingly. And it will basically, it's at that point in time, it'll give you a result to the user. So you may actually register multiple tools, and the GenAI will actually say, okay, to reach this result, I need to call multiple tools in sequence, and then it may use those multiple tools in sequence to get either different information or to execute code. And then it will work out as part of the sequencing operation or part of the goal intent analysis what tools it needs to invoke. And then it will just basically invoke those tools in the order that it needs to get the information that it does, and then it will process that those results, and then it may say, okay, I've got some results, I need to invoke some other tool to get some other results, and it will basically call those tools in sequence until it achieves the goal, and then once it's achieved the goal, it will process the information, then sort of give you a result. Now, if we want to sort of do a walkthrough for that, which is probably pretty relevant to sort of the question of data analytics. So maybe I have a question, or my user comes along and says, okay, connect to my database and identify the tables that have data inconsistencies in them. Report to me what those inconsistencies are and what I should do to fix them. So that's quite a complicated query. So basically what it's doing is it's asking the LLM to connect to the database. It's asking it to query results from tables. It's asking it to analyze those results for inconsistencies. It's then asking it to report those inconsistencies and also identify how to fix them. So that's quite a sequence of operations that has just been provided as one prompt. So what will happen is the user will pass the prompt in or the query. The tool will then sort of use that prompt to try and understand what the actual intent is. So it will say, okay, what do I actually need to do to actually achieve this goal? It'll say, I've got this goal, which is basically to analyze inconsistencies and show how to fix them. So what do I actually need to do from the various tools that I know about to actually allow me to go off and do that to reach that goal? So what it will do is it will say, it'll analyze the intent. It will then look through any registered functions. It will try and match those against this registered function metadata. So for example, it might say, I need to connect to a database, so I need to know about the connected database tool. I may need to list the schemas because I haven't been given a particular set of tables. I need to then query all the tables. And then I need to get information from those tables. So the three tools that might be relevant to it would be connect to a database, list the schema objects that database owns, and then get the information from that database. Get the information from those schema objects, which might include the actual definition of the table, and it might include all the information, all the data that's actually in that table. So once it's got that list of tools, it will then start to invoke them. It will say, okay, I've got these tools back now. I know the order of those tools I need to run them in. So I'll start to execute them. So it'll start to run those various functions. And in the tool execution, the first thing it might do, obviously, it can't get any information from the database without actually first connecting to the database. So the first thing it'll do is it'll do a connect to the database. Then it will query all the information as far as the schema goes. So it'll get all the tables back. And then it might actually go through each of those tables in turn, getting all the information from those tables, which might include the definition and all the table contents. Typically, it will convert it to JSON. So JSON is basically JavaScript object notation, I think, from memory. It's basically just a way of representing flat information. And it will use the actual functions that might use the particular database input output language for that database. It might be JDBC, it might be ODBC, it might be OCI, depending upon how, the language that you're using. And then it will return all those results as JSON back to the LLM. The LLM says, okay, I've got all these schema objects now. I've got all of this data. I've got all of this the goal that I've been given, and now I'm going to process that data, look for inconsistency. So it might cross tabulate different representations of the same information in different schemas. It will sort of compare those, and it will say, okay, I've got some inconsistencies here. It might decide that it needs to go off and do some more queries. So it might decide it needs to go off and touch some of the tables again to get some more information. Not in this particular case, because it gets all the information first, but it may when you were doing actual processing for real, it may have this loop that I talked about. It may decide, I need to go off and talk to other systems or get more information back from these tables before I actually can generate all these results. So it might do more processing, or it might just decide I've got all the results now, so I'll just do the final results. And those final results will be, here is the inconsistencies I identified, and here is the SQL that you might need to run to actually fix those inconsistencies. So that's sort of how it might do a walkthrough of trying to understand what the intention is, what the goal is, the tools that it needs to do to implement those intentions. It will run those tools and then sort of get the results back, and then sort of process the results to actually give you a final answer. It's a very simplified view because it might be a lot more repetitive in some of the ways it looks up tooling and the way it sort of interacts with those tooling, but that's the general flow. And then it generates the final results and passes it back to the user. So the last thing in this section is I'm just going to talk a bit about some of the main differences between the actual GenAI models themselves. I'm only looking at the three main ones, which is OpenAI, Gemini, and Llama. And this is my opinion. There might be other things. People may agree or disagree with some of these points. But this will also is where I'll talk about some of the pay, the way you pay for these models, and how you do some of the security as well, to looking at stopping the data leaving the environment as you have it. So the primary advantages of OpenAI, again, this is my personal opinion, it's a lot more cutting edge, and it's a lot more better at fine-tuning results. So I find that Google is very good at generating generic results, or being able to do much more operations than OpenAI can. So, for example, OpenAI is very finicky about the files that you can give it. You can load up. It won't load, for example, code. You can't give it code files, but you can with Gemini. So Gemini is very good at doing a first pass through. And then if you've got specific issues or specific problems, OpenAI generally tends to be a lot better at fine-tuning those problems than Google is. That's not necessarily always the case, but I tend to find if I'm looking at particular scenarios where I'm scratching my head about trying to understand what the problem is, I might feed specific situations into OpenAI, either Copilot or the ChatGPT, and it can more often than not come up with a better reason than Gemini is able to identify. So I find that the primary advantage of that using OpenAI is it tends to be a bit better in terms of being able to do reasoning, and it's a bit more cutting edge in the knowledge that it actually has access to. Gemini is very good at being able to support multiple types of data. So it can handle graphics very well. It can handle text, speech, code files, data files. It supports a lot more data out of the box than OpenAI does, and it will basically give you a better result for things like graphics than OpenAI does as well. It does have some challenges with that, but it does a lot better job than I find than the OpenAI does. If I use it for sort of things like give me a picture that represents X, Y, and Z. What comes out of Gemini is generally better than what comes out of OpenAI. And then you've got Llama, and the primary advantage of that is you have both open source and proprietary models available. Both OpenAI and Gemini are proprietary models. You don't get access to the underlying sort of, it's not source code, it's the underlying data models themselves, but you do have models that are open source within Llama that you can basically train up with more data if you so require. Oh, I just noticed we're almost at 8 o'clock now. I've got to stop. I've got a hard stop at 10 past. So we might have to sort of hurry along a bit. The cost and control, the technical model within OpenAI and Gemini, it's both proprietary. It's owned by the cloud, owned by those particular companies. You can't get access to it. Llama, there are open source versions. You can run it both online and offline. Cost and control, within OpenAI and Gemini, there are pay for token. It's basically a pay for token approach. So it's almost like a pay as you go model. So the more tokens that you process, the more you have to pay. Those tokens may be in the thousands or the millions, but you still have to pay for the more tokens that you use. Llama, it's generally some of those offline models are generally free. So you can have what's called offline models, which sort of allows you to download the model as it is in its entirety, and you can just basically run those queries against the offline model, and you don't have to pay for anything. However, the trade-off is that those offline models are very, very big. The sort of 30 gigabytes, 40 gigabytes, 50 gigabytes is not unknown, and the results that they give is dodgy. I tend to find they might be good at certain things, but if you ask them to do things that's beyond what they're specifically tuned for, you can get anything. Most of it will be garbage. Data environments, as one of the, I think it was David said, if you use the standard models and you pass customer specific information, that will go up to a cloud vendor somewhere, or it'll go up to a cloud somewhere, and it will breach your sort of environment, which is okay for open source. It's okay for public information or non-commercial sensitive information, but you definitely do not want to do that for financial information, legal information, or confidential information. So if you are wanting to do that for those sort of use cases, then for OpenAI, you can use something called Enterprise Edition of Copilot, which will basically make sure it's always within the boundary of your organization. And something similar for Gemini, you use what's called either the Gemini's Enterprise Edition, or you host all your data sources and use a hosted Gemini model. But again, you've got to pay for them. For Llama, you can run it on your device, and as long as your device has a model that's suitable for you, and your device has the necessary hardware that allows you to run it, then you can do it. But as I said, I find it's very, very painful. You've got to download a model that's sort of like 40, 50 gigabytes in size, which takes forever. And also, you have to have enough hardware, enough memory, and you have to make sure that the model that you're using is domain specific for you or has been trained with information for your domain. Otherwise, what you get, it might be complete bullshit. So I'm not happy with Llama models. They tend to not be very good. So some of the terms that we're not looking at, but things that you might want to look at in the future is A2A or ADK, agentic development. This is where you have root agents and you can delegate specific tasks to sub-agents. It's the sort of the microservice type model of agents. You have a specific agent which you might want to reduce the complexity of that agent by delegating subtasks to specific agents that then specialize in that specific subtask. It makes coding a lot easier. You've got model context protocol. This is something which is coming up a lot now. It's basically a way of standardizing how LLMs interact with external data sources and tools. So it's a new standard for interacting with external sources. Tokens are basically meters for how you interact with costs. So token limits often apply to things like OpenAI. If you request something that's going to require a lot of tokens to run, then that may hit a token limit, and the model may tell you, sorry, I can't do that because you've hit your token limit. And it's generally tiered. So the higher the tier, the more token limits you have. If you have a free token, sorry, if you're using a free tier, then the token limits are particularly narrow. I think it's 40,000, something like that. There's some tuning parameters that might also come across or might be useful to know about. There's temperature. That sort of you can use that to tune how deterministic or creative a model gets. If it's deterministic, it doesn't get creative. If it's creative, it can go down flights of fancy, and you can never guarantee a repetitive model or a repetitive response. I generally tend to use a parameter of 0.8 to start off with, and then I will tune it either down or up based on the sort of responses that I want the model to give me. The other one is the top P tuning parameter, which I think is specifically for Gemini, but it can basically tune how diverse the results that you look at are. So if you want to be very focused in the results that you're sort of looking at, then you can tune it down to 0. If you want it to look at as many results as possible and consider as many use cases as possible, I usually tune it to 1, unless I start to detune it. But 0.8 and 1 are the usual parameters I start off with for those two, and they can have significant impact on how a model works. So it's good to spend some time tuning them if you can. Right, hallucinations. So hallucinations are to do with when GenAI gets weird. So it often happens when a model either starts to make things up or basically misunderstands completely the question that you've asked. I usually see it a lot when it starts to make things up. It's when statements seem plausible, but they're not grounded in reality. So if you ask questions and it gives you a response that, it says, yes, this is definitely the answer that you're after. It will give you reasoning that might be very, very good, but the actual answer is in itself incorrect. And I've seen that numerous times. And why does it happen? It might be because the training data was too narrow. It might be that it had biases. It might be that the prompt that you're giving it is too vague or too complex. It might be due to things like political editing of reality. There's some countries that I'm sure you can think of that actually have standards for the AIs that they actually allow you to produce, and they have to have certain editing of reality in those AIs so that they think things that happened in history are not mentioned. Past sessions context might have an impact. So, for example, you might find that if you ask a question, you'll get a result, and if you ask the same question again, the result might be completely different based on the context that you've done since the first question and the second question, or the fact that the request that you give it is so ambiguous that it might take something, it might take a completely different meaning from what you've asked it. So you might say, I asked for example, a question on MCP earlier this week, and it gave me a result that was related to completely different type of MCP, simply because I didn't contextualize my query. I just said, tell me something about MCP, and I was meaning within the context of GenAI, and it took it to be something completely different outside of the context of GenAI. So the result was, okay, what are you talking about there? And then I realized it didn't understand which context I was giving it. It happens more than you think. So typical examples might include tool usage instructions. So for example, you may ask, how do I use a certain tool, or how do I use, what parameters do I pass down to a tool? Those results may be completely wrong. The pictures that you ask for may contain loads of mistakes. Gemini is very good at doing that. It'll generate great pictures, but they're full of inconsistencies and spelling errors. And then if you ask it to fix it, it won't. It will say it'll fix it, but it hasn't fixed it. So I, for example, I generated a picture and I sort of said, oh, you've got the spelling mistake there. Can you fix that spelling mistake? Yes, I'll fix that spelling mistake. You haven't changed the picture at all, but it still claims it's fixed it. It might answer questions that are to do with previous responses and totally ignore the question you've just asked. Had that happen quite often. It may make up references or articles that don't exist. This happens quite a lot in sort of academia, where people are using GenAI to sort of generate or do initial searches for articles that might be relevant to the areas that they're looking at. A lot of cases have come up recently where the articles that are being referenced or cites don't exist. They're just being made up. And that's because the GenAI, for whatever reasons, decided these articles exist, but they don't really. The last case might be you sort of ask a question once, you get a result back, then you ask a question again, and you get a result back which is completely different from the first question that you asked. I've had that happen a few times on me as well. So how do you resolve these issues? Well, you can resolve them by being very, very clear with the specific prompts that you're asking. So that's where you can do prompt engineering and roles. That helps reduce some of the ambiguity. The more ambiguous the answer the more ambiguous the prompt it gives, the more scope there is of coming up with answers that are wrong. Ground your responses with retrievals. So when we talked about RAG, what you're trying to do is you're trying to use tools and methods that will fetch information that will ground the responses that you give. So if you ask for processes, it won't just talk about vague processes that could be applicable to any company. It will actually talk about processes that are relevant to your specific company. And that's what you do with grounding. You might fine tune the model. So if you've got a generic model and you want to sort of fine tune it more with the specific things that are relevant to your domain or to your company, or maybe the specific use cases that you're interested in, then you can use more data sets to fine tune the responses that you give, which can then cut down on that ambiguity, cut down on those dummy responses. Or the last thing which often happens is that you have a human in the middle. So you get the GenAI to generate the results, and then you get a human to check it. And that email sort of assistance that I was talking about, that's why you get the GenAI to generate the draft. The human checks the draft, and if it looks okay, then it sends it. So human in the middle is a common approach for validating results. You don't just sort of get the model to generate something and then do an action based on that, because often you can't trust, well, not often, but sometimes you can't trust the results. But you can also use two models. You can get one model to generate the result and then another model to check the result. So that's an approach I often use. So GenAI content is not a guarantee of correctness. It may sound like it may be 100% confident that is the correct answer that it's giving you, but it may not be. So the more checks that you have, the better. Never trust something that's coming out of GenAI unless you know something about the answer that it's giving you.